Now you're currently thinking to yourself, Mrs. Golden, you forgot Avogadro's law. Okay, I left Avogadro's law out because we don't introduce it until we talk about the ideal gas law. So, Avogadro's law is the relationship between volume and number of moles. We know based on Avogadro's research that at standard temperature and pressure, which we call STP, which we will learn about in later in this video, 1 mole of gas will take up the volume of 22.4 liters. Okay? So this law is basically the relationship between volume and moles. Now we take this law and we combine it with our other laws and then introduce a constant, and we get what is the most useful law, which is the ideal gas law. Now you will note that you see the word ideal here. Most gases that we run into on a daily basis are ideal gases, and later on next week we will talk about what the difference between an ideal and non-ideal gas is. But for right now, when you are reading a problem, you want to assume that the ideal gas law is what you should be looking at. So we have P for pressure. This can be in a variety of units, but at whatever units you have on pressure needs to match your units for R. R is a constant. Okay, you notice in the bottom left-hand corner of your notes, you have a couple of places for R. We're going to write down our values for R as soon as I'm done with the ideal gas law. So volume should be in liters. Moles is just the number of moles, and temperature should be in Kelvin. Remember, Kelvin is degrees Celsius plus 273.15. Okay? So this is our ideal gas law. This allows us to change any of these variables or give you a single situation, and you can calculate any of the other variables. So if you have a conditions and you know the pressure, the volume, and the number of moles of gas, you can now calculate the temperature. You don't need to compare a before and after situation in order to be able to find out variables about a specific situation. Okay, so now we need to know our R values. So if pressure is in ATMs, then our R value will be 0.0821. If pressure is in torr, the R value will be 62.364. And if the pressure is in kPAs, then the R value will be 8.314. This first one up here is the one we will use most often. Atmospheres is the most frequently used pressure unit in chemistry, at least in the chemistry that we will be doing. Okay, at this point, you should have filled in all of these boxes, this box, and this box, which you can barely see in my, so I'm talking about this one right here. Now we need to talk about standard temperature and pressure. So, standard temperature and pressure, also known as STP, are 1 ATM in degrees Celsius. It's going to be 0, and in degrees Kelvin, it will be 273.15. Okay? So these are just conditions under which we conduct experiments, so it's easier to compare different experiments if we know that they're all under the same conditions. Okay, that wraps up your notes. I'm going to do an example on the back page next.